So I finally got around to designing myself some new parts so that I can work with my Chimera print head. And I decided to go ahead and show a little bit of how this assembly looks before I finish putting it all together, just so that you can see what I had to do. So it comes with the mixing head attached, and so you release the screws on the back side, and that releases the two heat break feed tubes here, and you unscrew those out of this, and the setup actually comes with the heaters in essentially a standard block, and it's designed where things just bottom out, so you've got a through hole threaded hole, and you screw the tip in all the way, and then you screw the heat break in the other side. But it comes with what is a volcano clone head. That basically what happens here is it changes the orientation of the heater and gets more heater contact, and then the tip is actually a longer brass tube down the middle, so the idea is you're getting more heat there. Now, a true volcano would also have a bigger nozzle. This is still a 0.4 millimeter nozzle, which frankly I'm fine with. I really don't want to be printing big sloppy parts. Even though I'm going to be printing big parts, I still like the resolution. I can always swap the tip out for a bigger one, but for right now this will be fine. But it gives me the two completely separate heads and the ability, ideally, to be able to push filament a little faster, just because it'll melt, or should melt better. And so basically now I just have to go and slip these back in, and then I'll show you my new mounting scheme for this. Now, you actually have quite a bit of flexibility in terms of how you can mount these heads. But for me, rather than putting them in line like you typically see where they're coming out one side or the other, from a wire handling perspective, it's much nicer to run these out the side. And that keeps things a little open. It also keeps the hot parts a little further away from the other components that I'm going to have here that you'll see in just a moment. So I think this will actually work pretty nicely. Versus turning them so that they're along the axis of this fan and everything. You'll notice that it does change which side the thermistor and screws are on, but frankly you would have an accessibility problem there anyway, that you can't get to those if they were side by side. So now we can look at what this is going to mount on. And so here's the normal mounting for the old head, and this just of course bolted here, and then you had the little tab down here that has your sensor on it. What I did was I printed up something that had a similar profile, and we'll use the same mounting scheme. I actually, this block is just a little shorter, and I shortened things up just a touch to get the maximum height. So I basically built this thing so that I get the maximum possible height on the bed. The other thing that I wanted was, if I were to mount this part like this, since this is in line with the essentially the y-axis, the short axis of the bed, I would lose an inch worth of my print space, or however much the spacing is, 20 millimeters or so. By what I chose to do was, instead of mounting it flat to that plate, I designed a plate that brings it out at a right angle, so that the depth that I'm losing is actually in the long axis, where I have more than enough length, so I don't mind losing that little bit of width out of the long axis of the printer by doing that this way. Now, the other thing I did, and I debated the best approach here, but basically I brought the sensor out so that the sensor will be essentially between these two heads, and about as close as I could get it without interfering with the fan and everything else. And what that will hopefully do is make sure that whatever the bed leveling is doing, it's doing it split between where those tips are. So if there's any variation on a small scale, the spacing for both tips should be about the same. So hopefully that will all work out. So I'm going to put a few screws in this and then show you where it goes from there. Alright, and there we are assembled with all the parts in place, or most of the parts in place. So you can see how the sensor blocks a little bit of the fan, but should still get sufficient airflow. So that's about as close as I can get it to the head, and probably as close as I want to get it. Now you'll notice on the back side I have a new duct for the print head, and I debated whether to add screws to screw this thing on. I ended up coming up with a solution to just slip it in a slot with a friction fit. Tolerances were a little bit off when this was printed, so I had to sand on it a little bit to get it to fit, but now it's in nice and tight, and I probably can't get it out very easily if I wanted to. The screws for mounting the head are underneath there, as well as the screws you can see for where if I need to adjust the height of either side of this. The one thing that I was realizing as I was screwing it on, because the tolerances, turns out, on my screw holes were not as tight as I might have wanted, what I need to do is, on at least one side, put a registration face to make that block be as square as possible to the print, so that hopefully then the base will be level. The other thing you'll notice here, the model, I didn't actually design the model for the print head. I found one on GrabCAD, and the top of that model, turns out, I didn't notice at the time, had ends more like this that were very flush to the block. This has the larger screw-in style. And so luckily it does still clear the strapping block I had for pulling the tubes tight, but it just barely clears, so I'll probably tweak that a little bit. But the idea here was the tubes and all the wiring and everything will come up and then go into the black tubing at the top, and I just tie wrap through those holes. So as it is, I might actually go ahead and try testing with this. Now, the one thing you'll notice is in the model, these heads face forward, which then would mean fighting with the wiring a lot more. So I like this arrangement of the wiring, but because the actual hot position is offset on these blocks, now it's just a little bit too close to my duct, and my duct is going to melt. So I get to redesign that anyway. So I'll probably reprint both of these parts with minor tweaks, but I may test it with this one before. We'll just have to see. So that gives you an idea what this looks like. I may go ahead and mount it up and take some more video there. Coming back to my print setup that I showed previously, this is my new mount with my dual tip extruder. And as you saw previously, we had a few issues by the time I decided exactly how I was putting these, and the fact that the model didn't match exactly what I was doing. So I've modified my model to actually reflect the way this one's designed, and have printed some new parts. So here now I have, it's going to look very similar, but I've done a couple of things. So you'll see this little 1mm ridge. See if we can get a good picture of it, trying to get the light to hit right. This one little 1mm ridge right along the edge. That's just a little bit of an alignment guide. I don't want to put too much along the aluminum there. But I just wanted something to butt up against when I'm tightening the 3 screws that hold the head on. And I also moved this bar up and basically made this whole piece just a little taller for supporting the tubing coming off of this when I reassemble all of this. And then I also reprinted my duct, went ahead and opened it up just a little bit to get some clearance around the heads, but still make sure that I had air flowing towards where it's actually extruding. It's possible that I will come along later. You know, a lot of the higher end fan cooling systems actually have ductwork on both sides of the head. I could potentially come up with a way of doing that. It's just a little bit of a challenge. It might actually take 2 fans or something else. But for now, I'm going to pull all these parts off, switch them to that, and see about reassembling this whole head. Then I get to re-level the bed and readjust all the thumb screws and then figure out how to wire the rest of this up. Alright, so working on mounting this, and wanted to show one tiny design oversight here, since I built this all as one piece and decided to assemble it all before I mounted it. The problem is that the bottom screw down here, there's no way to get it in past the fan and everything with the hot end. So what I'm going to do for that one screw is I'll just have to come in from this side and just put a nut on that side. So not a complete disaster, but certainly something that I overlooked when I was doing this in terms of the assembly order anyway. Now, my only other concern, and again, it should be fine because these are regular steel 440s and they didn't give me a problem, but these heads that are used for this fan are also just plain steel, so they're magnetic. But I don't think they'll affect the sensor. If they do, then we'll have to deal with that and change this. But let me get the PCB mounted up, and we'll take it just a little bit further. You'll notice, of course, that I'm currently leaving all the excess here. I really don't want to cut any of this off because I haven't decided yet how much I'm going to route that back through here. I don't think I'm going to bother too much with this PCB for most of my connections anymore. I'm probably just going to wire in direct where I can. But we'll see when I get that far. Alright, so there we are now. And of course I still have to deal with this mess up here. But as you can see, unlike the pile of tie wraps that I had to use to try to get this thing to stay upright, now I have just a nice way to clamp it right in there. Probably could have printed this even taller, and I debated doing so, but wasn't sure about clearance or anything else. So if I take another pass at this design, I probably will do that because I think it could stand to have that. But as you can see, it's all cinched up nicely. There's the one nut I couldn't get to, or basically where I couldn't put the screw through. The other thing I plan on doing on most of this, just to make it easier to change, is I'm going to I bought male and female versions of these connectors, so everywhere that I don't have a easily removable connector for things like the thermistors and that sort of thing, I'm just going to go ahead and build that into the system so that if I want to swap these heads or the heaters or anything else, I can do that without as much headache as what we're dealing with, especially with these little gray connectors here. So I wanted to show one last thing. I didn't push this all the way in yet just because I don't want to fight with it if I decide I need to adjust anything. But there's the cooling fan. Now, the only thing that I didn't account for here, and that is so close to borderline, it'd be very easy to fix. Basically, I am very close to the limit, so you can see that I actually bump. When I hit the limit switch, you can probably hear it click. I am just bumping the Y cable. Now, there was already problems previously that the wiring was rubbing that the Y belt. So, easiest solution for me for this will probably just be to make this so that the fan sits up higher, but we will see. If I do that, I probably can't mount it exactly the same. Alternately, I make the fan sit lower. Alright, so I fished the connections for the second heater up through the cable. Actually just opened it back up and stuck them in. You'll notice now that this 3/8 hose is just barely big enough to contain the wires and the 2 Bowden tubes. So if I was doing this from scratch, I would have just gone with the larger tube and probably done that all the way back. Now, this is as far as it got me. And so now I'm splicing in a set of wires to go the rest of the way. And in addition, I've got to get the thermistor the rest of the way. And while I'm in there, I'm actually going to fish another 4-conductor wire like this through that will go to the switches that are going to be for my reels, the runout switches. So rather than trying to fish 6 wires through power, ground, and common, that's the actual signal line, for each of those switches, I'm just going to daisy chain them, and that way I only need 2 signal lines, power and ground. Now, for this, I had debated actually soldering the, cutting the connector off and soldering it, but instead I just made myself a little plug from a pair of pins, and then I'm just going to slip a piece of heat shrink over it that will hold that in place indefinitely. And from there, I'm going to just 2 strands of ribbon cable all the way down to where the plug will be. And there, now we have both splices treated. As an added safety measure, I put just a small piece of electrical tape between the wires where I had soldered it. Not that I ever expect that to have come close to touching or anything else, but didn't hurt. Now, the only question will be whether or not the added thickness of this stuff gives me a problem inside the tube, just that it's not enough space. So I'm going to run that and that one 4-conductor ribbon cable and get this all down to the control board. Okay, so I'm finally back to working on my FT-6 printer, working on the dual extruder modification. This is after about a month of travel that's kept me out, followed by coming home to having my air conditioning unit for the upstairs go out, and there was no way I was working up here in the heat, so until I fixed that, I couldn't do much else. Of course, now that I have it working real nice, I realize that the vent is right over my setup here, so now that it's running nice and cold, we'll see what that does to me. But I'm back to trying to finish this off. Now, since the last time, I was just about done. I was working on getting everything routed through the cable down to the printer, and I decided that, it just wasn't fitting in that 3/8 inch tubing, basically this size tube that I had. And since I had a whole bunch of the 1/2 inch ID tubing, I went ahead and switched to that larger diameter tubing so that everything fit in nice and cleanly. So there's plenty of room, and potentially if I need to run something else, I can. Now, of course, the downside of that is I had designed my really nice new filament holder with all of my stops and everything. And what I had done was come back and redesign this to open up underneath for that cable run to fit through. And even, if I can get you the angle, you can see where we've got that perfect opening for that 3/8 inch tubing, basically a 1/2 inch diameter opening. Now I'm going to have to squeeze that new tube in or print another one of these with a larger opening. So we'll see if the tube goes in okay. If I still have trouble, looks like I'll be doing something else. But we'll get this installed and see what happens. All right, well, as expected, this stuff doesn't quite fit. And you can see that while I did manage to get things clamped down on either side here, it's actually bowing just a little bit around the added bulk of this bigger connection. You can see there's a little bit of a gap in between, partly because I don't have a screw in the, well, I do have a bottom hole here that can pull it together like this one does. I didn't have an extra screw to put in it. But anyway, so here you can see where it's coming out, just barely clearing the switch the way it is. And originally I was planning on using P-clips, but then I would have had to have T-nuts, and plus that would have caused this to hang out above or below the rail, so I just decided to use the little sticky back holders. And now I'm routing that cable on down, and it eventually comes through here. And as you can see, here we're routed. And now, ignoring the couple of pieces of tape that mark the two motors, which you should be able to see under here, if I can get this in the appropriate spot. Now you see the two black ones that are heater 1, and now the black and yellow is the new heater. I mean, they're both new heaters since it's a new head, but the new routed lines anyway. And then coming over right here, you see this little black and white line that's coming down that I put a plug on the end of it. That is my other thermistor. So now I have the bed thermistor and the two hot end thermistors, as well as the bed and hot end heat. Now the only thing, let's see, there's one other cable here. You can see this added end here. If I back out a little bit, it's basically I had one more of the motor lines, the 4 conductor lines for the stepper motors, because I had to buy, they came in a kit of 3 when I bought them. And so this last one will become my switch control. So power line and our power ground and 2 control signals. And I've got to figure out which of all of the digital inputs that we've got here I use for the runout sensors, but I'll rig up a cable adapter on both ends that will let me plug that in to the switches at the top and the sensor at the bottom, but that's something I don't have to finish now. Now, the only other thing that's not in this bundle that I don't think I'm going to even worry about on the back side is I do have my little roll of 24 volt LED tape, but while I might put one on the back rail, I'm really thinking I'm just going to hang it off of this front rail, so I would bring the power up the front side anyway rather than bringing it across the back. So with that, I still have to reconnect. Now this was the sensor that if you see my other videos, I had tapped off the power for this fan that's on the old heater. And you'll see when I took it off, I decided to cut it because rather than soldering in something new, what I'm going to do is solder a socket so that I can just take the new fan, plug it directly into that socket. This will still go into these lousy connectors there. And then the last 2 things I have are the thermistor lead and heater lead for this last heater. Now you'll notice, of course, I have a long bundle of wire that essentially for the other heater got me to somewhere about in here in this rail, and then I had to extend it from there. For the moment, I'm still going to use this board and the wiring the way we've got it, but I'm kind of reluctant to chop these off versus running the chance that I might have to run the second connection the same way I did the first. So I think at the moment I'm probably going to just leave this thing bundled, even though it's going to be more loss. I've got more cable here, so a little more loss in the wires. I think I'm just going to rig this up to use these as they are into this board for now. Alright, so just like that, our little piggybacked pair of leads is now got a connector on it so that I can just plug that fan in. So if I need to change things, move it around or whatever, it's as simple as unplugging that fan, not having to fool with these connectors that I now get to fight with to get these 3 leads back in to this leveling socket right here. So plus, minus, and signal. And once I get that, the other fan control here is for the new fan or old fan, which hopefully will still reach just barely. So this is my duct fan, which is not completely pushed on, so it would reach better if I had it pushed on all the way. But I left it off because just in case I needed to adjust things in terms of the nozzle height. And then we have our thermistor connection and our heater connection to be made. And on the thermistor, rather than chopping the connector off, we'll see. I might actually just add an extra connector there, although I have plenty of those crimp pins. I can always put a connector back on later if I need it. But that's the next step. Alright. Now, after fighting with all of these little gray push-in connectors, that of course when you go to push them, what happens is that this starts to slide. So it's a real challenge to get those connectors plugged in. But now I have them cleanly done. You'll notice that my fan lead just barely reaches there. Of course, I've got several more of those fans that I got when I bought these, because I bought a set of them. But that clears nicely underneath. There you can see roughly what my head arrangement looks like. The fan is just barely above the tips. I don't know how well that's focusing. I can try to get closer. There you go. So that should be what we get. And like I say, for now, I just left most of the bundle of that wire. I did cut the end off of the thermistor to be able to plug it in. But I'm just a little chicken to cut off my excess until I know this is the way I'm going to leave it and that it works well this way. But now the next step is I just need to get into the Marlin code and change all the variables to tell it, okay, I have a dual extruder and it has a separation in Y of whatever that is, which I've got to go figure out. And from there, we will be ready to do some testing, I hope. And be able to put a couple of reels up here, hopefully with my little feed items. They will load up and feed nicely. And we will give it a shot. Probably be another week before I get to it though. Alright, So since I have everything connected, it was time to power it up because I needed to calibrate the PID settings for temperature control. And so here we have it running. You can see the main cooling fan for the block running. It's got a lot of vibration. You can hear it's pretty loud. Anyway, so the fan's a little noisy. And a little bit of vibration, but hopefully that won't be a problem. If it is, I'll just have to replace the fan. At any rate, the whole point of this video is to primarily look at calibrating what that thermal block and heater does. And so what I have is I have already checked the M503 command to actually query what the settings are. I mean, I can read this directly out of the firmware, but here are the PID settings that are currently being used. And now we're going to go through a process, and this is the first time I've done it, so we will see. There's a couple of different websites I found. So there's the main just guide on the RepRap site. So this is the actual command, which is a lot easier to get from here because I can just copy, versus this one that has this neat little bitmap, but not terribly useful. This should be the same thing. M303E0S200C3. That's interesting. This says C8. So I wonder what the difference is between C3 and C8, but I'm going to do the one that's on the RepRap site. Okay, so I come in and hopefully I can paste that. And I send that. Auto-tune start. And so now you can see that it is increasing the temperature, I hope. Yep. Not sure what the B number corresponds to. And yes, if I go over and touch the filament or the extruder tip, it's definitely getting hot. Don't do that with a bare finger. Damp finger will work. But a nice sizzle off of it. And it should be going to reach the 210. We expect it to overshoot wildly because that's the intention of this test. Although not too much. But basically what this is supposed to do is wobble back and forth around the target temperature and try to come up with the best set of numbers to hit that target quickly. And this is liable to take a while, so chances are I'll feed this up. So the PID numbers it's spitting out are changing every time, so I'm guessing this is it's now in its loop where it's trying different things and tweaking the value. So if you look closely, what you can see it was doing is, I'm assuming the at 60 and at 0 is the power. So it would kick it on for 5 steps and then leave it off for 5 and just see what that curve did. So here are the new define values that I need to put into my code And so you can take those numbers and download them directly according to the documentation here. So you can use an M301 command and save it to the EEPROM. But in my case, I'm just going to write it into the code. And if we compare this to the previous command, which I think we can enter, so M503, let's hope this doesn't run off the screen. Quite a bit different. So the KP of 1708 versus 11.91, I of 1.5 versus 0.53, and a KD of 48.59 versus 66.59. So quite a bit of difference in the settings on this. You know, this has the volcano hot end, so presumably it heats faster, etc. Now, what I'm curious about, partly because of the difference in wiring links that I have currently, is whether or not if I ran this on the other hot end, if it would actually give me a different answer. I'm also curious, just if I rerun this, how repeatable the results are. So with that, we'll stop here and pick up once we get the firmware updated. Alright, so I decided to pull out my thermocouple and try to get an idea. Now it's just tucked in here at the top of this, but it should be in pretty good thermal contact. So I'm set at 210 and currently regulating there, and what I'm reading on the thermocouple is 199. So I'm a little low. I don't know if that means that the thermocouple is different. I mean, the thermocouple itself might be off. Now here I'm pulling on it a little, so it's got a little better thermal contact, a little further in. That got me to 202. So I doubt, now the question is going to be, can I get this thing out now without it completely getting screwed up? And now I'm trying to hold it on the bottom. I don't think I'm going to get enough thermal contact that way. I'm not about to go pushing on this with my finger. So, temperature's reading a little bit low, or a little bit high actually, so the actual temperature's a little low. So I'll try to decide if there's something else I can do. I also need to try to look up, see if the manufacturer of this thing says anything about the thermistor they provide. Somehow I seriously doubt it. And I don't know if there's a tweak available to offset this at all in the software or firmware, or how I deal with it. But we'll see. And I also don't know for sure that this thing's correct, although I'm pretty confident it's correct. Well, after just an incredible amount of trouble getting this thing leveled and balanced and having to replace motors and everything else, I'm finally attempting at least to print my first dual color print. Unfortunately, it's looking like the blue is not quite, well, actually I can't tell which one's printing. I guess it's, never mind, it's the red still printing. Kind of looking for it to actually change colors and see it print some blue. Best I can tell, it was getting close to printing blue on the original surround, so hopefully it'll work. You can tell it's definitely quieter. I mean, other than the fan on this 24 volt cooler. But otherwise, it's actually quite quiet in terms of the steppers. I wasn't positive that I had them configured properly, but they appear to be working, so. Now, I have this thing set up with hardware bed leveling, but it didn't actually run the level algorithm before the start, but it appears to be pretty good, at least for this. The nice thing here is there's no need for a stack to swap filament colors. So again, I want to see some blue show up, but I'll stop this and come back. Well, I'm getting close to done with my dual extruder benchy. And what I am seeing is that registration looks really good. That the colors, you know, as you would expect, since they're separate nozzles now, that you're getting complete color separation. But what we're seeing is a certain amount of oozing. So I'm still going to need a color change structure of some sort, either an ooze shield, presumably, or possibly a block just for it to quit dripping. I don't know. We'll have to see how this turns out. The other thing I'm seeing, and I'm assuming this is potentially due to the new stepper, but it's hard to tell with the ooze there. And if I come down here, that doesn't help from the camera standpoint. But the layer registration, you know, when I was running this before with the old stepper drivers, there was some stair stepping visible on the bow that doesn't seem to be there, but then again it could just be behind the blue ooze. So we'll see when this is complete and I clean it up just how this turns out. Alright, so here's my finished dual extruder benchy, and of course there's all of the ooze stuff hanging off of it that we'll see how much trouble that is to clean up. But also evidence of really bad stranding. You can see that that red strand goes all the way over to the extruder. So that is the problem I've had with this from the beginning, and I'm still having it. So after pulling it off and cleaning it up just a little bit, it's apparent that there's a Y registration problem, which would imply that the head is twisted just a little bit, because the overhang here on the top versus the overhang here is considerably more, and you can see that because this side of the rail is just pulled loose because it was barely overhanging, where this is, you can actually see red past the rail. So the rail's on the inside there, it's on the outside here. So a little bit of an X or a Y offset, because this was printing like this, which implies that the blue, which is extruder 1, is just slightly more positive than red. So that's something else to try to adjust. I'm going to attempt to find where to turn on the U shield and turn the temperature down a bit to see if extruding cooler will help reduce some of the stream. And we'll try it again. So I'm running at a lower temperature, but the one thing that I'm getting is that popping sound is the extruder actually skipping teeth, basically the filament slipping, based on the amount that it's trying to output. So I don't know. I think that's at least partly due to the lower temperature. But it still seems to be printing okay, but we'll judge when it's done. See the ooze shield being built around the part, so again, for a small part, this is still a decent amount, even though it's one layer. It goes, you know, outside the entire perimeter for the whole part. So and you can still see the lines just for this small amount of printing, where it's only doing red at the moment. You can see the lines between the part and the ooze shield as it goes to and from it. So, well, judging from this point in the print where it's finally started mixing colors, looks like the ooze shield is certainly helping. I don't know how much the drop in temperature is helping. I also offset by 0.5 millimeter in the y-axis in the software settings, which hopefully will now have that registering better between the two heads in Y. So we'll let this finish and see what we get. Alright, so here's our finished print inside its little ooze shield. And so now we get to pop that off and see just what the actual print inside looks like. You can see we still have our big long thread going over to the print nozzle. So if I can't figure out how to resolve that completely, that's going to be a problem. I think my next step is going to be to calibrate my extruders per what Matter Hackers recommends, and we'll see if we can figure out exactly whether they're over or under extruding. But let me pull this off and break off the outer ooze shield and see if our interior part looks more reasonable. I could have probably done this on camera, so the ooze shield just breaks away. It's, you know, it's not actually held solidly. Still a lot of stringing, making very rough edges to the part, but barring the stringing, this looks pretty darn good. Certainly greatly reduced the impact here. Again, still a lot of stringing between columns, but if I can resolve that independently, we might actually have a good product. The one thing I had done was did an offset of the axes in X by 0.5 millimeter, just as a guesstimate on how far off that is, which is indicating that this part's twisted a little bit somehow. Wouldn't be able to tell that from any visual inspection. But that seems to have come out decently. So with that, this will probably be the end of this video, unless I come up with a fix to my grip problem by calibrating, and then we'll see what happens from there. So hopefully there's some useful information for you, and I expect I'll post the parts that I've built so far for this extruder along with this video, and we'll go from there. Thanks.